Infrared spectroscopy or IR spectroscopy is an analytical technique used to identify chemical compounds. It works by exposing a sample to infrared radiation. Different chemical bonds absorb different frequencies of IR light, causing molecular vibrations. The resulting spectrum acts as a molecular fingerprint that helps identifying substance. Due to its ability to quickly identify functional groups and molecular structure, IR spectroscopy is widely used in chemistry, pharmaceuticals, food analysis, environmental monitoring, and material science.
Now, let's take a look at the advantages of infrared spectroscopy. The first advantage is that IR spectroscopy provides rapid analysis. So most samples can be analyzed within a few minutes, making it suitable for routine laboratory testing and quality control. The second advantage is that it is a non-destructive technique. So this means the sample is not chemically changed or damaged during analysis, so it can still be used for further experiment if needed. Another advantage is that very little sample preparation is required. So only a small amount of sample is needed, and with modern techniques such as FTIR, so many samples can be analyzed directly without complicated preparation. So this saves both effort and time. So another important advantage is that IR spectroscopy is very effective in identifying functional groups. Each functional group absorbs infrared radiation at specific wave number. For example, the OH, C double bond O, NH, and CH group each produce characteristic absorption peaks. So this helps chemists identify the chemical composition of a compound. IR spectroscopy is also versatile because it can analyze solids, liquid, and gases. So finally, IR spectroscopy has many real-world applications. In the pharmaceutical industry, it is used to identify drugs and ensure product quality. In the food industry, it helps detect food adulteration and analyze food composition. So it is also widely used in forensic laboratories to identify unknown substances found at a crime scene. So overall, this advantage make IR spectroscopy one of the most widely used analytical techniques in chemistry.
Limitations of IR spectroscopy. Although IR spectroscopy is very useful, it has some limitations. First, it can only detect vibration that cause a change in dipole moment. Therefore, gases like nitrogen and oxygen are difficult to detect. Second, when analyzing mixture, the spectrum can become complicated because different compounds may have overlapping peaks. Third, IR spectroscopy is not the best technique for the quantitative analysis because it is less accurate for measuring concentration compared to other methods. Lastly, water strongly absorbs infrared radiation. As a result, the presence of water can interfere with the spectrum and reduce the accuracy of the results. This limitation should be considered when using IR spectroscopy for analysis. In addition to these limitations, IR spectroscopy requires skill and experience to interpret the spectrum correctly, and overlapping peaks can make it difficult to identify functional group, especially in complex sample. This may lead to incorrect conclusion about the sample. IR spectroscopy is also less sensitive than techniques such as mass spectrometry. Therefore, it may not detect very small amount of substance. Because of these limitations, IR spectroscopy is often used together with the other analytical techniques such as NMR spectroscopy and mass spectrometry to obtain more accurate and complete results.
Last but not least is the comparison in application between IR spectroscopy and UV spectroscopy. IR spectroscopy is used to identify functional groups and analyze molecular structures by distinguishing different chemical bonds. For example, identifying an alcohol. On the other hand, UV spectroscopy measures an electronic transition and is ideal for determining concentration, though it gives limited structural information. A common use case is determining the concentration of colored compounds.